Comes on everyone. Let's start off. Let's see how to do this. Hope everyone has given a solid try. Okay. Sector is easy actually. So we have a sector. We take a thin arc at a distance x, angle theta, and the thickness is dx. So the charge on the arc is sigma. Area will be x theta, arc length into thickness. So potential due to the arc will be k q, that is sigma x dx theta by distance is x. X will get cancelled. Sigma k theta dx. So potential due to the sector, this we can work it out because there is no direction magnitude. Integral sigma k theta dx 0 to r. Sigma k theta r. Easy. That was the easiest one. Right. So the second one. How do you get for the circumference? Now there is a way to choose an element actually. So the trick is element. Listen carefully. So we know this result, sigma k theta r. Since you want to find the potential at A, this is what we are going to do. Take a thin sector like this, d theta, like this. So at an angle theta, take a very thin sector d theta, whose radius is smaller. So from the center, if you try to measure, this is capital R, this is capital R. So if that is theta, this is theta, we can use sine rule. R by sine theta is equal to small r by sine, this angle will be how much? 180 minus 2 theta. That would be sine 2 theta. I'll write the whole thing, sine 180 minus 2 theta. That would be 2 sine theta cos theta, 2r cos theta. Or you could have used simply, drop a perpendicular bisector and you could have solved it. That also would have worked. Whichever you like. So there we got the radius. So for this thin sector, now try to understand this point theta is 0. If you go up here, theta will be 90. If you go down, here theta will be minus 90. You're getting, if you go like this anti-clockwise, it is plus 90. If you go clockwise, it is minus 90. The sector is also becoming smaller and smaller. So here, if you see the radius of the arc, also the sector is also depending on theta. So potential at A due to an arc is K sigma. The charge would be, just now we derived the formula, K sigma K theta R. So sigma K d theta, let's directly do sector actually. K sigma d theta R, isn't it? Have a look at this. So for a sector of radius r, angle theta, the potential is sigma k theta r. So here, this is a sector whose angle is d theta and the radius is smaller. So the potential is sigma k d theta r.
Sir, why is there a K outside? Never
So
mind.
then we'll have sigma k and that r would be 2r cos theta d theta. This is a potential at A due to the sector. Getting it? And then you're done. Integrate. So potential at A would be 2 kr sigma integral cos theta d theta. Limits will go from minus pi by 2 to pi by 2. and you get this. And how much is this? Cos theta का integral is minus sin theta, no, sin theta only. So 2kr sigma, that would be sin theta, limits will go from pi by 2 to minus pi by 2. That actually becomes 2. So 4kr sigma, 4k is nothing but 1 by 4 pi epsilon r sigma. 4 will cancel, sigma r by pi epsilon. Check it out. 4k s r. What is
Sir,
S A
for this
Adrat?
question, I
Sigma.
tried
Yeah.
something else. Can I send you the working?
You should have done that before, right?
I tried to take strips of
So did you get the
some
answer?
length. So no.
Then it is wrong, no?
So, but why is it wrong? Why
Yeah,
is the method wrong?
figure it out. Let me know. I gave you 3 days to send it, and now you're saying, sir, today send it. Chalo, send it, I'll see.
Sir, we can take arcs also, right? Like
You
in the
can
previous one.
take like this.
Yes.
Hmm.
इसमें डबल इंटीग्रेशन लगेगा
Same
My
thing,
God.
na? Arc भी आएगा. This is also logic only. This also works. Actually, अच्छा वही किया मैंने देखो. I took arc and then I used sector, isn't it? तो double integration ही किया मैंने.
हाँ ओके मेक सेंस आपने पहले वो निकाल लिया फिर उसको
पहले मैंने ये किया इसके बाद किया. Actually इसमें क्या करेंगे? If you want double integration, then I will say I will take a small arc in this,
हाँ
and then I would say this element is r d theta dr, and उसका integrate करेंगे.
ठीक
It is the same thing.
हम्म
All got this. Ishan, भेजो ना. Send it. I'll see.
Sir, I'll do it once again properly and send after the
ठीक है.
class.
C का क्या हुआ?
I think उससे मुझे
Square plate.
I got sigma r by 2 epsilon naught, not pi epsilon naught.
You must have goofed up the limits or something there. You're
Could be.
pretty close by then. You must have limits ही mess up होगा. C का क्या करना है? अभी square plate का क्या करना है? Square plate is the most messy one. Now square plate again, you can take rods and do. But before that, let me show you something. Let's say if you take a right angle triangle. So if you take a right angled isosceles triangle, let's say this side is A, this side is A. So from here, at an angle theta, take a small angle d theta. So again, I got a small sector. So potential at A due to this sector is K, sigma K d theta into that radius r. So if this is theta, this would be your r. How much is this? Cos theta is A by r, or r is equal to A sec theta. So we have sigma K A sec theta d theta. So potential at point A due to the right angled isosceles plate. I'll just write right angled plate. Would be sigma K A integral sec theta d theta. Limits will go from 0 to pi by 4, isn't it? So at this point theta is 0, and at this point theta is pi by 4, 45 degrees. Sigma Ka, this integration is ln sec theta plus tan theta. That you should know. You can differentiate and check it out. Maximum they will teach you anyway. Others, do keep your cams on. So this is sigma Ka. Now if you substitute the limits, ln, that is root 2 plus 1, and that will be ln 0. Ln 1, that will become 0 anyway. So this is your answer. 1 by 4 pi epsilon. Yeah, sigma Ka ln root 2 plus 1. But this is not what I want. You want a square plate. So if you take a square plate has how many right angle triangles? 8, na? I found potential due to one triangle, isn't it? There are 8 triangles now. Let's call it O.
We can't do it by 2 triangles.
कर सकते हो, then limits भी change होगा.
Okay.
I just took one simplest triangle here, बस और कुछ नहीं. You can take. So then the potential at the center would be 8 times sigma Ka, because there are 8 pieces, ln root 2 plus 1. Clear, everyone? So if you see, all are connected with that sector thing only. There's another way to do this that you figure it out if you want to try. At the center, you can take a rod like this. So due to the rod, find the potential here and then integrate the rods. That also will work.
I did this for the circle one.
That also will work. Then you must have just messed up the limit somewhere.
Yes, sir.
Sir, इस circle वाले में I have this doubt.
Sir, in this one, 8, it will be a by 2 if I take each side here. Per side of that.
मैंने ज्यादा ले लिया ना.
It would be a by 2.
ठीक है?
Sir, वो disk
Because you want the
half disk होता then.
half disk.
हाँ.
Half disk, where will you get half disk?
If you gave in the question.
Okay. तो करके मुझे भेजना then.
अरे मैं इससे
ये-
समझ आ रहा, मैं कर रही हूँ ना, मैं पिछले 1 घंटे से ट्राई.
सर करके मुझे भेजो ना working. See, if you have some ideas, you should do and then you should ask for help. You should not throw your questions onto me. सर मुझे ऐसा लगा, आप कर लो. सर मुझे ऐसा लगा, ऐसा कर लो. सर मुझे ऐसा लगा क्या होता है? It's like,
I just need.
I'm telling you, Nasi, I'll appreciate your methods, but if you got an idea, try, send a working, and then let me see, what's wrong or something. भेजो. तुझे आप डिस्क कहाँ पे लिया?
अरे नहीं सर, मैं पूछ रही हूँ अगर होता तो. So I
हाँ तो ट्राई करना एक बार. अभी आइडिया अच्छा है, एक बार तो ट्राई तो करो.
chopped it into 2 half discs and I मतलब एक.
वर्किंग भेजो वर्किंग भेजो.
हाँ okay.
The problem क्या है ना, you guys scribble everywhere. The moment I ask you for working, you guys go blank.
हाँ.
करो ना अच्छे से. I'll tell you again seriously, this thing, right? 2018-19 times में ना, हैदराबाद में ना, this camp, big institutes and all, right? My friends were there, so they told me these people sat down and they started actually looking at exam में actually mistakes क्या क्या होता है. There was a research done, and these people, you know what they found out? The biggest problem is students ना, they scribble. They have a question, they'll scribble, and they'll, after spending 2 minutes, they don't get the question. They leave it, they go ahead, and when they come back after some time, they don't understand anything what they wrote. Again, they have to do from the beginning. That happens with most of you. You try a question, you scribble randomly. मैं ऐसा नहीं बोल रहा हूँ, beautifully लिखो. And then after 1.5 minutes of spending time, you don't get the question, you leave it, and then again you come back after an half an hour and you don't understand what the hell you wrote. You again start from the beginning. And these people found out, estimated, right? Students were losing time from 20 to 40 minutes. You initially lost already 1.5 minutes, ना? उसके बाद वापस आके try किया ना, वो भी गया. Now just imagine in every subject, even if you lose 4 questions like that, 4 into 3, 12 questions, 12 into 2, at least 24 minutes you are losing there. And आपको, you guys know, right? When you go to this mains and advanced exam, they won't give you big books for doing rough work. They will give you one A5 size booklet, which will have some 20 pages. Right? Some of you have a habit of 1 page में 1 question करते हैं हम. You will get slotted in the exam. And वहीं पे इतना बड़ा bench नहीं होगा. There is one big dabba computer and you have to put it there and you have to do the rough work there, isn't it?
So they don't
You
give
guys are not.
sheets?
If you are in a good center, तो they will give. अभी क्या पता? That day some sheets खत्म हो गया और they will say we won't give. You can't go and fight with them that day. मुंबई में generally problem नहीं होता है, but can't say. There was one center where the ACs were not working. Now imagine May 3rd week, summer में people were sitting and writing exam for 6 hours. Windows भी open नहीं कर सकते, क्या करोगे? Yeah, देखिए, I'll buy 20 sheets. They won't even let you take a pencil inside, gods. You're just supposed to walk inside the center. Play with this thing. See, I'm not saying this is the only way to do. There are multiple ways to do. Try karo na. Now I gave you an ideas to do. I was just trying to show you all this with a sector. You could have done this with rods also. That's not a bad idea. Idea अच्छा है. Answer match होना चाहिए. That's the important thing. Clear with this? Question अभी तक हुआ नहीं gods. Question था find the potentiality. How will I get this guy?
फिर वो
Actually, that would be a good question in the exam. पता है? That would be an easy question at mains level. हाँ रोत्सा बोलो.
आप दो बड़े राइट एंगल ट्रायंगल लेके कर सकते
नहीं इंटीग्रेट करने की जरूरत नहीं है एक्चुअली.
नो
Once you got VO आ जाएगा.
यू ऑलरेडी गॉट द रिजल्ट तो उसमें दो
ए से बड़ा ले रहे हो ना 2 times कर लेंगे. Yeah. Now see, there is a better way of asking this question. If it is a mains level question, they'll say like this. The square plate sigma, this is O, this is A. This is a cube. Uniformly charged. Now that using that integration, right, if you say actually becomes more of a max question. But if I ask you something pure physics question, right, they'll ask you like this. Find VO by VA. Let's get this. I just want the ratio, I don't want the values. And that means you won't have time to do integration in the exam. Cube to integrate nahi kar payenge. Cube integration is very bad. We won't be able to integrate that. At least I couldn't figure out how to integrate. Like I said, it becomes more of a max question. We are not interested in that. But if I ask you like this, find the ratio. This is a good physics question. Try. That integration, everyone again try it on your own. Huh? It's a good one. Like someone said, you want to use rods. You can try that. Seriously try that. Question bhi nahi aaya na, at least you'll get ideas how to integrate. That is how you learn. If you just keep, like I told you, right? Physics mein integration is actually easy. The headache is converting a problem into integration. How to do this thing? Let me do one thing. Let me show you for the square plate. You do for the cube. Now, look at the idea here. What is potential? KQ by R. That is the normal potential for a point charge. That means when you take out the dimensions, potential at the center O, right, is proportional to charge by side. Does it make sense? उसके ऊपर जो भी constant है. See, whatever is a constant, I don't care. The dimension should match with Q by A. But I already know Q is proportional to what? Sigma into A square by A. That means potential at the center is proportional to the side. So if you take a square sheet, the potential at the center is proportional to the side. That means if you take a square sheet of the side 2A, so this point will be the A now, isn't it? For the big square plate, the center will be the corner of one small square plate. So potential at A due to the big plate will be 2 times V naught because it is proportional to A. But this is due to 4 plates. So due to one small plate will be how much? So VA due to the small plate should be 1/4 of 2 V naught because 4 are contributing. So therefore V naught by VA ka ratio would be 2:1. Is that making sense? See, there is no integration, nothing. To get the ratio, this is the logic involved. Main idea is this: the potential should be in the form of k q by a to match the dimensions. Uske aage kuch number hoga. Think about it. Did you see this answer? It was same thing. This was the constant number, ln root 2 plus 1. No, I don't care what is that constant. It will be same for all the shapes. Matlab, for a given squares, the dimension should be q by a proportional to. Now, can you do for the cube the same logic? Anyone has a doubt on this logic, please ask me. So the logic was, it is a square plate, center is a symmetry. So the potential should be proportional to the charge by the side, because it is dimensions. The constant, I don't know, whatever it is. And q is proportional to sigma a square, so potential should be proportional to a. So if you take a bigger square of side to a, potential should be double. But the big square is made of 4 small square plates. Much of each square plate is giving you 1/4 of 2 v naught. Try for the cube. This is the kind of question you can expect.
VA by V naught or V naught by VA?
Find anything now, God. क्या फर्क पड़ेगा? Is that the most important one? पहले ये सब लॉजिक निकालना इंपॉर्टेंट था ना, वो सब छोड़ के दैट इज द मोस्ट इंपॉर्टेंट वन. 1:1/2. ईशान क्या है आंसर? रिपोर्ट प्रॉपरली ना. Who reports an answer like that? 8:1 नहीं, 1:2, 1:2. Yeah, it is the same. See, idea is the same. So even for a cube, the potential VO is proportional to Q by A. Q is proportional to rho into A cube by A. So proportional to A square. That means if you take a big cube, of side 2A, now this A will be the center of that big cube. So VA for the big cube will be A square, right? So 4V naught. And there are 8 of them. So 4A due to that small cube will be 1/8 of 4V naught. V naught by 2. Answer is same. You can do this kind of logic only for symmetrical shapes. Clear with this? Because a big cube will have 8 small cubes now. This thing has 8 small cubes. So 1/8 of it. These are the kind of questions you can expect in the exam. That integration is like, the examiner really goes mad and really decides to harass you guys. So that is the kind of questions. Out of 20, you can expect 2 or 3 like that. But these are the kind of questions you can expect more. Clear? Next one. Next one. Field on an axial line.
So
It's pretty. Right?
Sir, the force between two rods.
That is a homework. You have to send me a working.
Okay.
Those things, like I said, those are all mathematical questions. You guys try. Take your time. Take a week. Aram se, no hurries.
So like उसमें double
Try.
integration or something लग रहा है.
Yeah, double integration आता है. Double integration से better क्या है ना? Try कर. चलो तू try कर. Then I'll help you. See, don't be in a hurry, like, hurry, immediately answer bolne. So those kind of things which I say, take your time now. Because even if you take a week and figure out on your own, it take 2 weeks and figure it out. Once you figure out, you'll have better idea about it. The moment I give you a hint, you'll get an answer, but you will lose that ability to figure it out. Right now, it might take 2 weeks. After 6 months, it will become 2 hours. Next year, by the time exam is ready, you will take 2 minutes. But somewhere it will take time. I solved Erido while traveling in bus. Not because that time we didn't have smartphones. And every day in the bus, I used to travel for 45 minutes one way. So I used to write the questions of Erido in a paper and put it in my pocket. Anyway, bus में तो standing था, seat भी नहीं मिलता था. So what I used to do, I was bored anyway, right? Now तो you guys take out PUBG, YouTube videos, Instagram सब करते हो. Again, I'll tell you, see, it is not like, your generation is bad or something. Our generation didn't have enough options to get distracted. That's it. That is the only thing. You guys play PUBG, we used to go and break heads. We used to literally get into physical fights. बस इतना ही difference है और कुछ नहीं है. So I used to read the question, put it in the pocket, and then I used to keep thinking about the question because I didn't have an option. I can't write with pen and paper. Initially, it was difficult, but then after some point, right, after 2 months, 3 months, 6 months, right, I started, I used to visualize the entire question in my head only. I just used to come home, take a paper, write the solution. It was not easy. It used to take time, but I could figure it out. So you guys need to do that. Don't be in a hurry. Like, that's why I told everyone to solve Verido weekly, make a target of 10 questions. I sent you those questions also. But you guys think like, that if you solve a lot of questions, sab set ho jayega. You guys have a wrong notion about physics. It's not about quantity. If you solve physics, 100 questions karo achhe se. Take one book, finish 100 questions. Take some tough book like Erido or, maybe you can do Pathfinder ka that level 1 ka questions. Or you can do level 5, level 6 of my booklet questions. Those are pretty good. Take one source and try them on your own. If you really want to improve physics, that's the best way to do. So there, we got a ring here of charge q and radius r. At a distance x, there is a point V on the axial line. Find the field and potential. This is a standard result you need to remember. But let's try to derive this. This is an easy derivation. I could clearly see the difference, right? Meaning your seniors right now, and even 2022 ka seniors are there now. 2022 seniors kaise bataye? If they sent a doubt, matlab that guy must have really tried and he had no other option other to send me. They used to send, and the moment I start to answer, they used to say, sir, stop. I used to write 2 steps and they say, sir, stop. Meaning, that's it. You gave me a hint, don't tell the answer. They were very prideful. That guy in that batch, Adit karke tha, Adit, 338 rank tha, 2022 ka. That guy, Max sir gave a problem and he took it as a challenge and he didn't sleep for 2 days. People think like they're weird and all, but only weird and crazy people get things done. Put a little fight. It's okay if you don't get an answer. You guys, exam में अगर answer नहीं है तो you guys feel bad. अरे यार marks जा रहे हैं, marks जा रहे हैं. But if you actually go to any topper and see, they feel happy about it. अरे यार, I'm getting something new to learn. ये क्यों नहीं है आया? They get excited. You guys see an exam and you feel terror. देखा? I gave you one advanced paper बीच में याद है? Everyone messed up big time. The paper was tough. Instead of taking that paper and solving for 2-3 weeks आराम से time लेके एक question अच्छे से solve के you should have figured it on your own. You would have learned much more than solving 100 questions of some book. How many of you actually did that paper again? Tell me. अच्छे से पूरा paper एक question कौन solve किया? There 1 2 3 4 5. अभी बाकी लोग सोचो. You guys keep saying sir improvement नहीं आ रहा है, physics question थोड़ा tough लग रहे हैं. That's because you don't do the tough work. Instead of doing everything, you should have done that. That paper was good, right? No, I'm not saying paper ऐसा आएगा, but there are a lot of concepts you could have learned in the paper. How do we do this? See, this was easy one. Let's take a small piece, dq. This angle is theta. So this field will be dE. I told you multiple times. Whenever you integrate a vector, always integrate the components. So So here you can clearly see the vertical components cancel out. So electric field at P will be integral dE cos theta. So this will be K dq by distance square is x square plus r square cos theta. But if you observe something here, everything is constant except dq. So this is K cos theta is x by x square plus r square whole power 3 by 2 integral dq. So k q x by x square plus r square whole power 3 by 2. Do mug up the result. We'll have a similar result in gravitation and one more in magnetism. Potential is the easiest one. Kq by root over r square plus x square. Scalar quantity doesn't matter. This would be a proper bits level question. They'll ask you plot the graph, or they can ask you set the x is equal to 0, field is 0, the value will go up and come down like this. Value will go down. This value is r by root 2. We have done this before for that hexagon question if you remember. Same function आया था hexagon में. It was the same function. देखो y by a square plus y 3 by 2. The constant was different, but the function was same. So if you differentiate, you'll get the exact same thing. Here the graph is right and left thing. Here the graph thoda ye hai. We took right positive, left negative. So the peak value occurs at r by root 2. This was the main question. For an axial line, find the maximum field at which point? R by root 2. Have a look at this. You can copy down these results. The graph, the two results, and r by root 2. Those are the important ones in this. Anyone confused with this, please ask me. Let's see a question. Can I go ahead? Next thing. We have a ring here, charge q, radius r, 4q, 2r. Let's call this A and let's call this B. Let this distance be 2r. We have a charge minus q mass m. Find work done. To take a charge from charge minus q from A to B. Get it? Easy one, just formula substitution. Neil, clear with the questions? Yeah. Swastika, Vidyut. Try. Let's go. It's a little weird to solve. Let's see whether it did the same thing. Most common mistake is this. See, work done by external force is straightforward. Work done by external force is charge into potential difference, isn't it? Kinetic energy is anyway zero. The work done by external force is change in potential energy plus change in kinetic energy. Since you're moving slowly, this is zero. So if you can find VB, VA, my job's done. Another mistake is this. Potential at A is K Q by R at the center plus K. You're forgetting potential at A due to the ring, and this ring also you have to include. Isn't it? Potential at A due to everyone you should take, not only due to your own ring. So K 4Q by this distance will be how much? 2R, 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 2 root 2R. That is the potential at A. The most common mistake, you forget the potential due to the other ring. So potential at B will be K Q by this guy ka distance is R root 5 plus K 4Q by 2R. Done. Substitute will get the answer. Clear? So just be careful with that. You need to, when you say potential at A, it is due to everyone present. Next one. Clear na, Abhinav, Adrit, Arjun?
Yeah.
Yes, sir.
We have taken a disk. Sigma radius R. So this is the action line, point P at a distance X. Find the field at point P. If R tends to infinity, what does it mean? Can you explain what exactly happened? Or what do we get? Or let me write like that. Explain the result for R tending to infinity. First, let's get EP. I taught you for a ring, I'm asking you for a disk. Try. Involves integration again. How do we start? Just to give an idea, we'll start like this. Take a ring at a distance X. You already know the ring ka result. So then integrating with a disk. Try. Right. Becomes an infinite sheet. See. So at a distance x from center, so at a distance x, take a ring dx. Let this distance be some z. Did I give this as x क्या? काम करते हैं. Let this be x only. Let this be some z, and this is some dz thickness. So charge on the ring is sigma 2 pi z dz. So potential field you want. So field due to the ring is k q ring, the distance x by radius z square plus x square whole power 3 by 2. This is the formula due to the ring. So the field due to the disk will be integral k q is sigma 2 pi z dz x by, remember here x is constant, z is a, this is constant. I should have given actually this as z and that is x, but okay. Z square plus x square whole power 3 by 2. Z ka limits will go from 0 to r. So 2 pi sigma kx integral z dz by z square plus x square whole by 3 by 2. This you must have done in max. If you have done integration, you would realize this is integration by substitution. Put z square plus x square is equal to t square. Differentiate this. So z dz will be t dt. Substitute the limits. 2 pi sigma kx integral t dt by t cube, meaning it becomes quite an easy integration actually. That would be 2 pi sigma kx minus 1 by t square. So minus 1 by t ka integration. And let's put the limits. Sigma is what? K is 1 by 4 pi epsilon. So sigma by 2 epsilon x minus 1 by t root over z square plus x square. Limits will go from 0 to r. Sigma by 2 epsilon. If you put, again be careful, these are z ka limits. If you put z is equal to 0, you'll end up with 1 minus x by root over z square plus x square. This is the field.
नीचे
नहीं z नहीं आएगा, r आएगा.
हाँ
This is the field due to this thing. Now here, if you say r tends to infinity, the disk actually becomes a infinite sheet, meaning it will cover the whole region, isn't it? And that second term becomes 0, because if r is infinity, this whole term becomes 0. E becomes sigma by 2 epsilon. We get a pretty interesting result. The field is constant. No matter how far you are from an infinite sheet, the field is always constant. That's a pretty good result. Field due to an infinite sheet. Later on, we're going to prove that using Gauss law, but you can prove this with this also. This is the field due to the disk, and there is a field due to the infinite sheet. Have a look at this. Clear? Did everyone got the integration part? Next one. Next one.
फिर वो एक बार आप पीछे जा सकते हो वो x नहीं आना चाहिए ना ऊपर आएगा
ये बाहर x है ना रे
so but
x is a constant here. है ना x तो है बाहर. In this formula kqx x क्या था? Distance from the center, isn't it?
हाँ तो माइनस सिग्मा x 2 पाई एप्सिलॉन नॉट और नीचे 1 बाई x आता है ना -1
वो कैंसिल हो गया था.
हाँ तो
अरे
आपने
दो टर्म्स आएगा ना रे गॉड.
हाँ तो आपने वहाँ पे x क्यों लिखा है वो नहीं रहेगा ना
कहाँ पे? यहाँ पे.
नहीं 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 नीचे फाइनल में 1 माइनस
बिकॉज यहाँ पे x by x आएगा
अरे अरे it's आ जा
ना. आई एक्सपेंडेड दैट ना. लिमिट्स डालने के बाद दो टर्म्स आएगा. क्लियर ना? क्लियर ना उत्साह?
So,
माइनस
हाँ कुछ.
इसका इंटीग्रेशन -1/t आता है अब आप इसमें
राइट.
1/r² + d² -1/d नीचे रहे वो बाहर d रहेगा अंदर -1/d रहेगा तो नहीं उसमें ऊपर नहीं आएगा ना वो
I substituted t का value again ना here. Where did you get confused? Did you get this? There is an x here.
हाँ सर वो ठीक है सर
इतना तक ठीक है.
I'll send you my marks
इतना तक ठीक है.
हाँ हाँ ठीक है
Then देख लो. Maybe I must have goofed up, but I don't know. हाँ कुछ you're saying something.
सर यस आई मीन प्रीवियसली हमने जो सेक्टर के लिए जो आंसर निकाला था हम क्या ऐसे निकाल सकते सेक्टर के लिए लाइक 2 पाई से डिवाइड करके
है गॉड. सेक्टर तो कहाँ पे निकाला था? सेक्टर का सेंटर पे निकाल रहा था.
अच्छा यहाँ पे x को 0 पुट कर देंगे
बट क्यों रखना है? क्वेश्चन इज फाइंड पोटेंशियल डिस्टेंस ऑफ x. एंड पोटेंशियल नहीं पूछ रहे, फील्ड पूछ रहे यहाँ पे.
राइट आई मीन सॉरी
This is the center. So this is a part of a sphere. Let's say this angle is theta. Half angle. Okay. And this whole thing has a charge sigma. This is a part of a hollow sphere. Meaning if I take theta is equal to 90, I'll get hemisphere. If I put theta 180, I'll get full sphere. Meaning if I had completed this now, it would have been like this. Something of that sort. It is of a part of a hollow charged sphere. Find the field at the center. Potential is easy. How to take elements for a hemisphere? Remember, this is how we found sun for hollow hemisphere. This is how we choose elements. This is one of the most important thing I taught you, how to choose elements for a given shape. It doesn't matter which chapter it is. The moment you see the shape, you should know how to choose elements. Then comes that remaining the particular chapter ka thing. Track. exam में you can expect a hemisphere का question. So we are doing for theta. So why will you use projected area? Projected area is for what? Force is pressure into area, something of that sort. I'm asking a field at a point. तो point के लिए area क्या होता है? Arey, don't use the first thing that comes into mind, Ray. Exam you will do such kind of mistakes only. Happens, you'll get something in the mind, na? Then think, okay, does it make sense? Because now to I'm there to tell you. Exam who will tell you? You guys will just mark something and come. And then you will say, sir, silly mistake ho gaya. Silly mistake nahi hai. You guys are not training your brain properly. Try. There is no shorter way for this. You have to integrate. I showed you how to choose an element. So if you want, I'll show it again. So once you took an element, can you see it? Doesn't it look like now that formula? Field due to a ring. ऐसा नहीं होता है रे. I'll keep changing questions. No, I'm actually teaching you field due to rings. Isn't it? मैं disk नहीं पूछा था. Disk में क्या use किया? Field due to ring on axial line. So if you want to say that way, then yes, I'm doing something similar, but it is not disk. Let's see how to do this thing. You get a decent answer though. Suppose अगर सोचो ये एग्जाम में आ गया क्वेश्चन एंड यू डोंट नो हाउ टू डू, हाउ विल यू गेस? दैट इज द फर्स्ट थिंग आई विल डू इन द एग्जाम. हाँ अर्जुन
Put the value of theta like as
बोलो
you know,
कितना?
like for the full thing, if you know it will put like 2 pi now.
Right, so
Then you know the full values.
how much? How much?
We
I'm
can
just saying.
How much?
For a hollow, it's 0, na?
0 na. So if you put theta is equal to pi, answer should give you 0.
Yeah.
If you put theta is equal to 0,
It won't even exist.
that means still you should get 0, right? मतलब there's no charge na.
What do we get? What is even?
मतलब there's nothing there, 0 charge, so there's no field. Isn't that the meaning of it? Now see, physically it doesn't exist. Max doesn't know that, no? Theta 0 meaning there's nothing there. So theta pi is full sphere. Theta 0 means there's nothing there. Let's see how to choose an element. So at an angle alpha, we will take a thin slice like this. You will get a ring like this. Remember, alpha ka limits are going from alpha is 0 here, alpha is theta here. So alpha ka value is changing from 0 to theta. This distance would be, this is r cos alpha, and this distance is r sin alpha. Basically, r sin alpha is the radius of the disk, the radius of that ring. We know the field due to the ring on the axial line is k, q. What is q of the ring? Q of the ring is sigma. That area is 2 pi r sin alpha, the radius, into the arc length rd alpha. This width here is rd alpha. So circumference into width will give you the area of that ring. So k, q ring x by r square plus x square whole power 3 by 2. This was the formula due to a ring. If I substitute the values here, k 2 pi r square sin alpha d alpha, and what is x? X is the distance, which is r cos alpha, by r square plus x square is nothing but again r square, so that will be r cube. field due to the ring will be k 2 pi r square r cube will cancel. You end up with sine alpha cos alpha d alpha. Hope I didn't miss anything. Yeah. Then field due to that what do we call this? Part of a sphere. Pi k 2 sine alpha cos alpha is sine 2 alpha. Limits will go from 0 to theta. K is 1 by 4 pi epsilon, so you'll get 1 by 4 pi epsilon. I definitely missed out something. Sigma I missed out. And then sine 2 alpha ka integration is what? Minus 1 by 2 cos 2 alpha. Limits will go from 0 to theta. So sigma by 8 epsilon cos 2 alpha cos 0 1 minus cos 2 theta. Sigma by 8 epsilon 1 minus cos 2 theta. That's your result. Let's check whether we're getting the answer. If you put theta is equal to 0, 1 minus 1, 0, great. If I put theta is equal to pi, 1 minus 1, 0, right. Options, at least that much we can figure out. Meaning maybe you'll be able to eliminate two options. Answer to आएगा नहीं, but yeah.
How did you find Q of ring? I didn't get that.
Q of sigma into area. Area of the ring कितना? Circumference into thickness.
So thickness is like tilted, no? It won't.
When you cut it, it becomes flat, right? You are not there, I guess, when I taught you, na? देखो, this is already alpha. If you cut it, and if you open this, what do you get?
Okay, see. Oh, yeah, it makes sense.
This will be already alpha. And this will be 2 pi r.
And I remember I had asked you for that flat surface वाला, तब it won't be that ना RD alpha.
Which one?
वो एक semi circle था. And you said I can't take RD alpha in that.
वो तो कोन का ले रहा था ना? That you are doing for cone actually.
Semicircle. अच्छा.
That I remember something like that you're doing for a cone. ऐसा कुछ element ले रहा था. कुछ तो था. There, this was DH. You are taking DH as the radius. You should take the slanting length as the thickness. I think it was that. But फिर भी देख लो एक बार भेजो. I'll see. Play with this. It's a decent result. So if you take if you put theta is equal to pi, what do you get? That would be a decent question, right? If you take a hemisphere, the field here would be theta would be pi. That would be 1 minus or minus 2 हो जाएगा. Sigma by 4 epsilon. Decent answer. And if you put theta is equal to 2 pi, we get full sphere. That's right, sphere. Then the field at the center is 0.
It should be theta equal to pi, no, for the sphere, and pi by 2 for the hemisphere.
Mistake किया मैंने. तो ये कितना होगा? Sigma by 8 epsilon, no? This is 0. No, right, only 4 epsilon only.
4 epsilon, yeah.
4 epsilon only, 4 epsilon. There, so full sphere at center is 0. But the full sphere, right? There is another way to do this. There's an interesting way. See. In a full sphere, if you randomly choose any point, and if you choose this part of the sphere, and if you choose this part of the sphere, okay, and let this radius be r1 from here, and let this radius be r2 from here, this angle and this angle are similar. So this area, a1, is some constant into R1 square. Isn't it? C is some constant. Similarly, here area of this entire region A2 will be also some constant into R2 square. Therefore, if you look at the field is nothing but K Q by R square. So Q is nothing but sigma into area, which is C R square by R square. R square cancels off. So E is constant for a given. That means whatever field this A1 generates, the same field will be generated by A2. You're making sense? If you take randomly any point in the sphere, the field due to this point and the field due to this point will always cancel. Therefore, E bar due to area A1 and A2 cancel out. Therefore, field inside is 0. Field at any point inside the sphere is 0. Basically, both of them have same solid angle. If you try to see, logically socho, here the area is less, but distance is also less now. Here area is more, so there is more charge, but distance is more, right? So the field is kq by r square. That q is also depending on the area. Because you are closer, the area is small. So r square will cancel off. Just a way of proving it mathematically. You don't need to know the proof, but there. So not only in the center, anywhere inside the shell, it is 0. Have a look at this. It's a decent proof. Clear? Vartika? This thing is making sense, the second one? Or maybe I'll do one thing, but I'll just write it on the next page. Now, there are some results for the hollow sphere. We'll not be doing the derivations. We'll see them in Gauss law. These are very important derivations, results, right? Especially in mains, right? Whenever they ask questions on gravitation and electrostatics, half of the questions were always on hollow and solid sphere. So we have a hollow sphere, charge q, radius r. Small r is the distance from the center. So the field is given by 0, r less than r, basically inside. This we proved. K q by small r square. This is r greater than r. This also you can prove, but okay. Gauss law made it more easy to prove. So if you see, the field outside behaves as if it is a point charge. So if you try to plot the graphs of E versus R, the field is 0 till capital R, and then it becomes a discontinuous function, decreases. So the field suddenly comes out of nowhere. The potential is kq by capital R, which is constant, R less than R. Outside, it behaves like a point thing. So this is one best thing about the spheres. Outside, they just behave like point charges. So if you look at the potential versus R graph, I think you should note down all this stuff, people. Put it down. The potential is constant and then drops to 0. Note on the formulas. We're going to do problems based on this. That means if Earth was a hollow sphere, and if I throw you inside, you'll be floating inside. Isn't it? Clear? Next one. Turn in the page. Anika, go ahead. Aditya, Saina, Rehan, Ali, clear na? Arjun?
So
Arjun.
basically, like to remove, like suppose you had like a charge inside and you want to remove it like to a point A, the work done would be constant regardless
Zero.
of.
Yeah, so therefore potential difference is zero.
Okay.
Meaning you can say it is constant. Exactly kitna hai wo calculate from, you can calculate the center, no? And then from there you will say it should be same everywhere inside since work done is zero. Yeah, you can do that. That would be the proof actually for potential. Uniformly charged sphere. Let's say the charge is Q and radius R. KQ small r by r cube. Outside is KQ by r square. For r less than r. R greater than r. Here the function is continuous. The function will increase linearly and then drop. Now, out of all, right, this is the most deadliest one. I think in 2021, 22, I don't remember, but this was a question directly in the exam. Find the potential at r by 2. KQ by 2 r cube 3 r square minus small r square. Out of all these formulas, the potential inside a solid sphere is the most messed up formula. R less than r, outside is again KQ by r. And there is something more interesting here. This is another goof of people do. What is the potential inside a solid sphere at the center? People say 0. If you observe here, if you put r is equal to 0, at center the potential is 3 kq by 2r. It's not 0. So the potential actually starts at 3 kq by 2r, and if you see the graph is actually parabolic. It's a minus r square thing like this, and then it decays function. So the starting part of the graph is a parabola. Field inside is 0 at the center. So I think in a flow, now people think it is 0. Just try to understand the meaning of 0. Huh? If the potential at the center is 0, infinity ka potential is 0, that means you did not do any work to take the charge from center to infinity. Isn't it? That's the meaning of it. Put it up. That thing in the center, the potential is quite, this is a quite important formula. Straightforward questions you can get in bits and mains. And most people goof up that and come.
So is the graph differentiable at x equal to r?
X is equal to R. हाँ,
Yes.
इसमें तो differentiable है. It's the same value, ना? Potential is differentiable.
The same value होने से it's not always different.
नहीं, but यहाँ पे continuous का है ये. Same value और continuous function है ये. Basically, बाद में देखते हैं ना. We'll write E is dv by dr. So E exists, so we should exist. We should be a continuous function. अब ये तेरा max में नहीं जाता है. That max will take care of it. There is a derivation of a solid sphere. नहीं, अनिका इतना करने की जरूरत नहीं है ना. पर solid sphere क्या कर सकते हैं? You can take it as a hollow spheres and then integrate, isn't it? You know the hollow sphere का result ना, उससे solid sphere का result निकाल सकते हैं. Hollow sphere is the fundamental. Once you got the solid sphere आ जाएगा. All clear with the results? Let's see a question. Let's see a question. We have a solid sphere and we have a hollow sphere. hollow charge shell. Let's say the charge is q and the radius is 2r. This charge is also q and the radius is r. So, and this is a solid sphere. Concentric. They have same center. O is the center. This is A. This is B. This is C. So O to A, this distance is r by 2. O to B का distance is 3r by 2. O to C का distance is 5r by 2. ठीक है, you got it. So find the field and potential at OABC. This will, if you do this thing, you'll remember all the formulas. Find the field and potential at OABC due to both of them. Whenever I say field and potential, due to everyone present. Or epsilon cos. Remember anyone, na? Chalega. Remember KQ or ep sigma, whichever you like. इतना तो conversion कर सकते हो exam में.
So can you show the formula again?
What did you do when I gave you time to write? You didn't write. Here. You have to remember, right? If you guys are saying इतना मैं remember नहीं कर सकता हूँ, chemistry and organic will kill you guys. So always think of like that. Physics में 4 formula, chemistry में it will be like 40 things you have to remember. And हर 2 formula में एक exception आता है. In that way, physics is much better actually. Let's get this thing. I'll show you one safe. This is how I will do. So let's say hollow sphere, solid sphere. So if you can find both of them, I can just add them up. So at O, so if you take field at O, hollow sphere 0, solid sphere 0, because at the center it is 0. So the only thing you have to see is the point inside or outside. If it is inside, use the inside formula. If it is outside, use the outside formula. Potential at O for the hollow sphere inside, kq by 2r. Remember the radius is 2r. For a solid sphere, it is kq by radius r. So just add them, you get the answer. You're getting how I'm doing? So do for A now. Like that, you just find the field and potential due to each of them and then add them, you'll get the answer. Field is vector quantity, you'll add in terms of directions.
So for the solid C, it should be 3 by 2 KQ by R, no? VO.
I was testing you guys. I forgot. Let's see. 3 KQ by 2R. Today people got JEE ka centers. One student got Thakur College, it seems, and that is in Borivali, na? Somewhere it is there. Thakur College, it seems. Some people got IIT Bombay. So, last time some people got even in this Banduk also. So EA, hollow sphere ka field is 0. A is inside. See, think like this. A is inside the hollow sphere. right? And for the solid sphere, it is k q, distances r by 2 by r cube. You can simplify. Direction would be I cap, right side. Potential at A would be kq by 2r. Here the formula is kq by 2r cube. Yeah, it's not a good one. 3r square minus r by 2 whole square. That's why they asked this as a question. So potential is a little messed up. So add them up. So EB, this guy is 0, luckily. This guy is kq by 3r by 2 ka square. Again, direction is I cap. VB, this guy is still inside. No, this guy is outside. So kq by 3r by 2. You see, finally, this thing will have kq by 5r by 2 whole square. This also will be kq by 5r by 2 whole square. So it is outside for both of them. Potential also will be kq by 5r by 2. Outside is the most easiest one. Check. So the one thing you should know, like whether the point is inside or outside, and use the appropriate formulas, and you're done.
So
Hmm.
suppose you had like two concentric solid spheres like of different charge densities. Like
How
one
will you have two concentric solid
like the
spheres?
beach wala part is like hollow of the bigger one, and usme you put like another,
Okay. Okay.
and then and like if you want to find the field outside, can you subtract the field of the
Directly
bigger
डाल
like the
सकते हो,
whole
because see, you can do because logic देखो. Don't think of it as a solid sphere with cavity. Think of like this. Think of this as a shell.
Yeah,
For this shell, the point is outside.
yeah.
I'll put the charge at the center. So for
Hmm.
every shell, for all the shells, the points are outside. So you can take all the charge at the center.
Okay,
That way.
got it.
Easy? All got this? So we have a solid. Let's do one thing. Let's do a theoretical question. We have a hollow sphere, hollow shell. Charge Q, radius R, doesn't matter. This guy is the center. I don't care about that. Let's say there is some random point A here. So question will be like this in the exam. What is the direction of field at point A? So options will be like this, like this, like this, like this, like this. ऐसा options होगा. Which of the following is the direction of the electric field at point A? A is a point on the surface, that disk, but not the center. So they'll give you 4 arrows. So which of the following is the direction of field at A? Arjun, feeling, or you have a proof?
So I think maybe using something you showed earlier.
ये ऐसा नहीं होता है. ये क्या proof है?
Arey,
ये तो maybe
like,
something, I think. So I'll ask you one thing. Will you be able to mark that answer in the exam?
sir, actually it's a booklet question, I remember.
तो वही problem है.
But sir, I think I can prove it also.
Prove कर लेना. I'm giving you 1 minute. Try.
Okay.
Okay. Most people are saying 3, 5. Exam, your hands will shake, right? When you don't have a solid proof.
So matlab
You
you
guys
want to
shouldn't.
tell it?
You guys. No, no. You think na. You once you got it, you tell me, nah, sir. I understand. I know how to prove it. If you say that, I'll believe you.
Like I'm not sure if it's that, but I think it's that.
ठीक है. Nowadays, so when I teach juniors, na, I give them options like that only. They'll get an answer sometimes. So I tell them, did you get the answer by astrology? Did you get the answer by feeling? Did you get the answer by science? So I give them 3 options. So some people do get the answers by astrologies and some feelings. Rarely they get an answer by actually solving.
Google should be the last option.
देखो क्या करना था उसमें logic. It's a good one. Consider one more shell. ठीक है? Now I don't know the answer, but this much I can say there should be a parallel component and there should be a perpendicular component. Assuming you can divide the field into 2 directions. By symmetry, even this guy should be E perpendicular and this guy should also be E parallel. Symmetry, no? It should be towards the center. Now, if I combine this, I'll get a full sphere. And now I know EA should be 0 because in a hollow sphere, the field is 0. That means if you add these two, we will get 2 times E parallel component is 0. Therefore, E parallel is 0. Make sense? That means there should be no parallel component, right? Did you get the logic? If I take 2 hollow spheres and assume the field is E parallel and E perpendicular, E parallel and E perpendicular. So when I combine both the hollow spheres, the net field should be 0 because it's a point inside a hollow sphere. So E perpendicular will anyway cancel. So E parallel plus E parallel are adding up. So therefore the answer is 3. So this is a very good result. Huh? So if you take a hollow sphere, all the points will have the field in the same direction. Magnitude is different. Magnitude we can't calculate. That is actually more messed up because there's no symmetry. Clear? Easy proof, but it's a good one. Any doubts on this? Great. Let's see one more like this. Before doing this, let me ask you one and then we will go ahead, or else it will become too tough for you guys. Let's say we have a, should I take solid sphere, hollow sphere? फर्क नहीं पड़ेगा actually. Let's say we have a hollow sphere plus q and radius r. We have another hollow sphere like this. Half hemisphere, okay? This is an hemisphere. Let's say charge is q2, r2. Should I put sigma? Better. Sigma to r2. नहीं, q लेते हैं. Let's say this charge is q2, r2. This is q1, r1. Both have a common center. Find force between them. Plus, na, so they will repel.
फिर अंदर वाला is hollow.
Actually, फर्क नहीं पड़ेगा रे. Because field outside is anyway doesn't matter ना. तो ले ले दोनों hollow shells ले लेते हैं. This is also hollow shell. It actually won't matter, but ठीक है. Because field inside, field outside a hollow shell or a solid sphere is same. Is this question clear what we did? So we have a half hemisphere positive charge and a full sphere positive charge. They have a common center. See, if it had been full and full, what is the answer? 0, right? Because field inside the hollow shell is 0, so there'll be no force between them. But the moment you make half shell, there is a force. They'll get repelled. Find the force between them. Ishan, this is what you asked me last time.
Yes, sir. नहीं
क्या
हुआ था
नहीं,
उसमें.
right?
Right.
चला अभी
हुआ.
करते हैं. Think it's a good one.
उसमें से I think even the internal sphere was half.
हाँ, but पहले ये करते हैं ना.
Hmm.
That's what I said. First, let's do this. वो directly उसमें jump करेंगे तो it'll be too hard. हाँ, Saina, what happened? Not well. Sleepy. चलो चलो solve. This April, May is the most craziest time for me. On one hand, I'll be, your seniors who are there, they ask all high level, advanced level problems. Your juniors, on the other hand, they ask all dumb things. I have to keep switching between both of them. Your juniors to highlight only. I give you an exam. Sir, I think this question 15 is wrong. Why? Because I didn't get the answer, sir. मतलब, heights of confidence, मतलब question ही wrong है. मुझे आंसर नहीं आए मतलब wrong, super confidence. Then I explain them. Oh, I didn't think like this. So one question I can understand. 6 questions, 7 questions, they think paper is wrong. There is one question we did recently, a good one actually. It's like there are 3 vectors, mod A, mod B, mod C, all equal to 2. I did for you guys also. I don't know whether you remember or not. The angle between any 2 vectors is 60 degrees. Listen to the word. Angle between any 2 vectors is 60 degrees. Find the resultant A bar plus B bar plus C bar. How will the vectors look like?
Like a squished tetrahedron.
They can't be in the same plane.
हाँ,
ये
yeah.
60, ये 60, ये तो 120 हो जाएगा. They have to be like this. 60, 60,
Yeah,
60.
squished tetrahedron.
हाँ tetrahedron वाला.
Tetrahedron वाला क्वेश्चन था वो.
Yeah, it was there in our test also.
अच्छा क्वेश्चन था वो. इसको क्या करना है? Got anyone got the idea for this? Show you projected area.
So I was going to ask that, but I did not.
See. So इसमें लॉजिक क्या था ना?
Is it really projected area?
I'm just joking. So at this point here, take a small area, ठीक है? dA. So here what will be the field? K Q1 by R2 square. Agreed? So on that small area, what is the charge? So Q on that small area, QdA, will be sigma into dA, that is sigma 2. And let's repeat as sigma 2 for now. So the force on that dA will be field into Q. What is the pressure? Pressure is force by area. So this is E, Q is sigma 2 into dA by dA. Sigma 2 into V. Isn't it? And how is this pressure? This pressure is radial, isn't it? At every point there is a pressure away from the center. So the entire outer shell will feel as if there is some kind of pressure which is pushing away. Does it make sense? And if you have pressure uniformly on the surface area, how do you find the force? Pressure into projected area. Is that making sense, everyone? And what is sigma 2? Sigma 2 is Q2 by 2 pi R square. So therefore, the force on the outer shell is pressure into projected area. Isn't that how we define pressure as force acting perpendicular to the surface area? So pressure is sigma 2 into the field into projected area is pi R2 square. There you know all the values, dump them, you'll get the answer. That's your force. By Newton's third law, that should be the same force acting on the full shell also, inner shell. Is this making sense, everyone? At a distance, if we take a small piece dA, and then from there we go. Do have a look at this. There, fluid mechanics of projected area. This is what I keep telling you. You should always be able to relate different things. Clear? So you can substitute the values, you'll get an answer there. Now, using this as a logic, using this as a base, this you'll try as a homework. What if I have a hemisphere and I have another sphere? Where this is Q1, R1, Q2, R2. Getting it? Both are half and half. Common center. Hemispheres. Find the force between them. You will need the previous result. You will need it. No, it won't be half. Symmetry nahi hai na, right, Ishan? How can it be half? When you say half, you know what is the meaning of that? You are saying force between these two is same as force between these two. Symmetry nahi hai. It is not half of it. Do you guys think this both will be same? This and this are same. It's not symmetrical, right? It's not same. All got this?
Can you just show the previous one for? Okay, yeah, thank you.
Clear, na?
The one, can you? Yes, sir, thank you.
Next one. So that you'll try as a homework. Next class, we will discuss this. You have to prove that. Try. 35. This is also a good one, see. So we have a uniformly charged sphere. Let the charge be, density is rho, and the radius is r. Rho is the volume density. Now, because of the positive charge, the shell will repel itself, isn't it? The charges on the sphere repel each other, generating a pressure inside the sphere. Meaning, think of like this. All this positive charge will repel this guy. All this will repel this guy. So all the forces will keep adding up, isn't it? Find the pressure as function of x, where x is the distance from the center. Find pressure at a distance x from center. The B part you'll do as a homework. Find the force between upper and the lower hemisphere. You'll need the A part for the B part. We'll do the A part now. This is a pretty good one, right? Same thing we can see again in gravitation also. Here rho is the volume charge density. Think how will you do this? How do we approach this?
So by pressure, you mean pressure on the layer of charge at a distance x, right?
ऐसा नहीं होता है नरेश. When you say pressure at a point, it is a pressure at a point. It's not any layer or anything, right? Pressure at a point meaning if you put a small area there, it is going to apply a force. So pressure at a point, that's it. So when I say there's a liquid
Yeah,
and I say pressure at a depth h is rho g h, what do you mean by that? That entire surrounding the pressure is P naught plus rho g h, isn't it?
yeah.
So let me ask you like this. Can you tell me where is the pressure zero?
Center.
चलो center करते देखते कैसे है. So चलो here the force is zero. You're getting something here. So this charge is being pushed here and both are connected here. This charge is being pushed here. This is being pushed here. This is being pushed here. All these forces are adding up here, isn't it?
Sir,
So
get this.
just imagine like this thing. Ishansi, we tie you here in the center and we keep, some elephants on all the directions and pull you. So
Okay,
because
sir.
all the elephants are pulling you with equal force, the force cancels out. You should be safe, right?
No. Dead.
So there. Remember this statement, always the free ends will have tension zero. You know where we did this? Circular motion. Free ends have zero tension. If you see the limits how we took, because on the free end, right, there is nothing to touch, isn't it? If there is a tension there, there is no one there to pull you there. So free ends always have zero tension. So let's see how to do this thing.
So can you explain the free end part again?
I'll show
I
you.
wasn't there that time, so.
So at a distance x, take a thin sheet, okay? Let the area be A. It's a thin sheet. It's a small area. So the charge Q will be sigma rho into, and this thickness be dx. So at a distance x, you're taking a sheet of thickness dx. So the charge would be rho into A into dx. So the diagram would have looked like this. Isn't it? This is how it looks. That area is A. This distance is dx. So here the pressure is P into area. The pressure from outside is P plus dP into area. Remember, convention, we always assume the functions are increasing. With increase in x, we'll assume pressure is also increasing. And the electrostatic force will be P into Q. So from this equation, we can see PA will cancel. dP into area PA plus PQ is P plus dP into area. PA will cancel. So this field is K Q small r by r cube, and the Q is rho A dx is equal to dP into area. Clear? So area will cancel. So you end up with dP is equal to KQ. Sorry, this is KQX by R cube. So KQ rho by R cube X dx. And then what do we get? Yeah, we're done basically. So dP integral pressure, this guy would be KQ rho by R cube integral X dx. So here the pressure, this will go from R to X. This will go from 0 to P. Now see why I'm saying the pressure is 0 on the outer surface. Should I say it's pushing from inside? See, on the open surface, right, at this point the pressure is 0 because if the who is pushing it? Tell me that. If you say there's a pressure here, where are you getting this pressure from basically?
All the charges inside the sphere are,
So that is pushing this inner surface, right? So this part of the surface is being pushed, isn't it?
yeah.
See, if you're standing here, if someone is pushing like this, your back part of the body feels under pressure, isn't it? The front part has nothing. Right?
Yeah, so as a whole, I am feeling pressure at that point now. तो इसका मतलब pressure तो
It's
होगा.
the surface, right? You're saying pressure on a surface, isn't it? Force on a surface. So the thing is, what is the force on this surface? What are we getting is the force from the inside, isn't it?
So inside and outside, there is a difference in the pressure.
That's what we wrote here, P plus dP and PA. So I'm just wondering here, should I take P plus dP outside and inside? Because I'm getting a minus sign cut difference actually.
So the final answer is rho K Q by 2R cube into R square minus X square, you know?
Okay, I'm just having an issue with the sign actually. Because if everyone, how do I put it down actually? Because basically, yeah, I'm writing it reverse actually. Let's not write it as pressure. Let's write it as tension. Then later on, we will say tension by area is pressure. Then this is T plus dt.
फिर क्या प्रॉब्लम था प्रेशर के साथ?
What direction I'm getting messed up actually?
Why? मतलब अंदर से तो सही था.
No, it's like, see now, what is pressure now? Tension by area, right? So we are right, when you draw an FBD, right, this outer surface, we are assuming it is pulling, isn't it? Surfaces pull each other.
Oh, okay.
So
But
this surface is pulling this way, that surface is pulling this way. Isn't that what tension does? Tension always pulls. So something like that. So, and later on we will say tension by area is pressure. So on this surface, the tension by area, pressure will be this way. तो एक minus sign आएगा actually. But forget about that. That sign is fine. But did everyone is clear why the outside the pressure on the outer surface is 0? Getting it? So there is no force acting from outside here on this surface. So anyways, so when you do that, and this pressure is nothing but T by area. So this will be dt is equal to minus EQ. So the minus sign indicates that actually the tension is increasing when you go inside. So dt by area will give you dp. Nothing, I just wanted that minus sign actually. So we get pressure is equal to kq rho by r cube, and that minus will go r square minus x square. That's your pressure. And what is q? Q is nothing but rho into 4 by 3 pi r cube. So substitute the values here, you'll get the answer. Pressure on the outer surface is 0. Basically, free ends and open surfaces have 0 pressure. Simply, there is no one else to push the surface on the outside. I agree, there's a pressure here, but there's no pressure here. You can actually substitute the value. What do you get? You get a decent.
कि जो pressure है वो अंदर की तरफ you mean force लगा रहा है, like it's pulling.
Which one?
वो minus sign की वजह से, so you're saying it.
Basically, यहाँ पे क्या हो रहा है ना? I'll tell you. See, imagine this part is there, this part is there. Na? Imagine they have a rope between them. ऐसा सोचो. They're tied by ropes. They have some strength, right? Because if that is not there, what will happen? The sphere would have flown away, right, due to repulsion. So basically, ये electric field का force था. Because of that, you're getting tensions. So this tension is pulling, so the tension by area is pressure. So basically, what tension pressure both are in reverse direction. Why बोलो इतना tension मत लो, just take it as P. You'll just have an issue with the minus sign. So ignore the minus sign.
ठीक है, sorry.
I was just doing all the tension thing to get that minus and और कुछ नहीं है. Substitute करो value Q का value substitute करने क्या आएगा? This is 1 by 4 pi epsilon. You'll get rho square by r cubed. 4 by 3 pi r cubed. 4 pi will cancel. You get a good answer, right? Rho square by 3 epsilon r square minus x square. I think that's an answer. 3 आएगा. Just check that again. KQ rho. Ah shit, I forgot there is a 2 also now here. X square by 2 ना integration में. ठीक है, substitute that, you'll get something. You'll get a rho square expression. So that is 1 by 4 pi epsilon. Q is a rho 4 by 3 pi r cube. One more row. There's a 2r cube. So r cube goes off. 4 pi goes off. You end up with rho square by 6 epsilon. Chalo, that's your answer. It's a good result. This is the pressure inside a sphere. I will write down here.
So yeah, the tension was basically the repulsive force, no? Just
Tension is that repulsive force. Actually, क्या हो रहा है ना, Arjun? Think of like this. This whole sphere is repelling this.
yeah.
To keep it from flying away, someone has to apply tension in the opposite direction. That tension by area is pressure.
So one thing I didn't understand, how do you know the difference between the forces is a small thing? Like
Because
how
it
do
is
you
an
know
equilibrium. Because
Acha,
it is an
okay,
equilibrium.
fine.
If it is not an equilibrium, the sphere would have blasted and gone away, na?
Yeah, right.
All clear with this? Forget about the minus and tension. If you're confused, forget about it. Just take it as pressure. यहाँ पे minus and नहीं आएगा. You'll get x square minus r square. So just reverse it and done. Because that is obvious. If you get x square minus r square, you're getting negative pressure. But it's a pretty good one. Have a look at this. Try to understand. Now, the second part is a homework question that you try. Find the force between upper and lower hemisphere based on this. Let's see one last one. We have n identical mercury drops. Mercury is conducting, so they behave like conducting spheres. N identical spherical mercury drops. Of potential V are combined. So we have n drops, identical ones. Potential is V for all of them. They're all combined to create one big drop. Find the potential of the big drop. Let's get this. We have seen something similar like that in surface tension, remember? Something similar. This is a proper mensural question. V by n power 1 by 3. We have one answer. Anyone else? V by n power 1 by 3. We have 2, 3. Okay. Let's see. V n by 2 by 3. Chalo, we have one different answer at least. So if you combine first n drops, volume is conserved. So let's start like this. Let the charge on this thing be Q. 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 So that means what is the charge? NQ. That is the first thing. Charge is conserved. Next thing, volume. N times 4 by 3 pi small r cubed is 4 by 3 pi r cubed. So n power 1 by 3 small r. Now potential of the small sphere is kq by small r. Potential of the big sphere will be k total charge, which is k n capital Q. Most of you forgot that n in the numerator. And the potential is capital R. So n k q r is n power 1 by 3 small r. So that is n power 2 by 3 into v. That's a mistake you did. Rehan got it right. Most of you forgot that charge also becomes n times. Surface tension mein such that was not there. Surface tension mein that S into the change in surface area, S was same. Here the charge is messed up. When you combine n drops, charge will be nq. And the volume is conserved. You have to use both the concepts. Clear? Next one. Try this as a homework. We'll be discussing this. This again a standard result. So we have a solid sphere with a cavity. Rho is the volume charge density. O is the center. O dash is the center of the cavity. So there is a point P here randomly somewhere. Find the field at point P. That is one homework question. We have a hollow shell with charge density sigma and radius r. Sigma is the surface charge density. B is the breaking stress. And T is the thickness. Thin hollow shell. And T is much less than R. So the first question, find pressure on the shell. Just like solid sphere, even here the charges will repel each other. Find maximum sigma so that the shell does not break. Clear? So totally have 4 homework questions. This one is a pretty good one. Then this thing, force on upper and lower hemisphere. Then this guy and this guy. So try all 4. So next class, first thing in the class, we're going to discuss these things. So do give it a try, spend some time. Okay, so with that, we'll wrap up for the day. So any doubts, anything in today's class, any other doubts you can ask me, or else you're free to leave. So take care, stay safe. I'll see you guys again next week on Wednesday. This week, our test is online till Tuesday, so make sure to give. I think, see, in the paper, it sometimes once in a while, 1 or 2 diagrams will be missing. Don't worry about it. You leave it, you'll get bonus for that. So, but focus on the remaining questions now. Out of 25, chalo, 1 question diagram missing. So do, show some mercy on me. I have to make the paper alone, so there will be some goof ups.